Hello students, and welcome to lesson 21, which is factoring by splitting the middle. Splitting the middle can also be referred to as the AC method. And you might actually prefer to call it the AC method because once you learn in a second how it works, AC actually reminds you of the process. So splitting the middle is what we're going to start off with, and then the full method is usually referred to as the AC method. But I've seen it called both ways, so whichever you prefer, quite honestly. All right, so in this lesson, we're going to factor trinomials by splitting the middle, so using the AC method. And then afterward, I'm going to show you the shortcut for when the polynomials have an a equals 1 coefficient. So when the leading coefficient is a 1, then we can skip a whole bunch of steps, which is what you've probably seen in the past. All right, for the application, it's actually a research question in this case. A lot of students ask why I use the AC method, or splitting the middle, instead of a different method they've seen. And the reason is that the AC method is the best. It works all the time, and I mean, really, it is the best. And it uses what we learned in the last lesson, lesson 20, which is factor by grouping. So it builds on things I've already shown you. But because some of you have seen other methods, what I want you to do is take one of the examples we do in this lesson and use one of the other methods to solve it. So I want you to actually research another method. One such method might be bottoms up, is one students have frequently seen. But what I want you to do is Google or go on to AI, really anywhere, get a textbook, and look up an alternative method for factoring trinomials. Okay, because that's what we're doing here is we're factoring trinomials. Look up a method other than the AC method and try it. Okay, use it for one of the examples I do here with the AC method and see which method you prefer. But when you're doing it, I want you to actually write out a sentence here that tells me which method you prefer. That way in class, I can go around and see, hey, what are my students enjoying? And maybe in the future, I can use one of those methods instead. But for now, no one has proven me wrong. I think the AC method is the best. All right, so split in the middle. This is going to look a little complicated because there's a bunch of steps at the top, but I promise you it's really not that bad. So given a polynomial in standard form, ax squared plus bx plus c, our goal is to split the bx term into two terms, which we will call dx plus ex. When we're actually doing the math, we don't have to write dx and ex, all this terminology. This is just a general description of how we do it. Okay, the rules here are that d plus e, so the two numbers we come up with, need to add together to be the b term. So right here, this b in the middle, we want to find two numbers that add together to equal b. But those same two numbers, d and e, have to multiply together to equal a times c. Okay, so the way we're going to do this is we're going to make what's called a t-chart, the most simple kind of chart you can think of. In the top left, we'll write the product, a times c, where it's the first number times the last number. And in the top right, we'll write the b term. On the left side of the chart, we're going to then list out sets of two numbers that multiply to yield a times c. So for example, 16 is 8 times 2, but 16 is also -4 times -4. So there's multiple options for how you can get numbers. Okay, then on the right side of the chart, we're going to add together each of these sets, and the set that adds together to equal the b term will be the set we want. So let's go ahead and practice. For number 1 here, this is in the form ax squared plus bx plus c. So we can see then that the a value is 2, the b value is -5, and the c value is 3. Usually I won't write all this out. We will just say what a, b, and c are. But since it's our first one, we'll clarify that a is 2, b is -5, c is 3. So now the process is we make a t-chart. So big letter T. In the top left, we're going to do a times c, and the top right, we're going to do b. So since a is 2 and c is 3, a times c is 6, and then b is -5. Okay, so now the next step says to write out sets of two numbers that multiply to give me +6. So we might do 6 times 1, we might do 3 times 2, or this may not have came to your mind at first, but we could also use negative numbers. So -6 times -1 also equals +6, and negative 3 times negative 2 as well equals positive 6. Okay, so we have 4 possibilities for what might work here. Now on the right side of the chart, we have negative 5. What we're going to do is we're going to add together the numbers on the left. So 6 plus 1 equals positive 7. That does not equal negative 5, so that's not the right one. 3 plus 2 equals positive 5. That's close, but it's not negative 5, so still wrong. Negative 6 plus negative 1 equals negative 7, still wrong. But then the last one, negative 3 plus negative 2, that equals negative 5. So what we want are these last two numbers because this negative 5 matches the b term at the top. All right, so now all we have to do is split the middle of this problem where the b term is this negative 5x. We're going to split it into negative 3x minus 2x. Okay, and the way I got those numbers, the negative 3 is right here, the negative 2 is down here, so it's the two numbers we got for our set. But I need to include the x on it because I need it to be negative 5x when I add them back together. So notice negative 3x minus 2x gives me negative 5x. So I split my middle term. But we have to leave the rest of the problem there. So we still had 2x squared in front and plus 3 in back. All right, but that's all there is to it. We have split the middle of this trinomial. Right now, that's all we're going to do. And the next slide, we're going to actually factor this thing. Okay, for number 2, we're going to go a little bit faster now. We have 3x squared plus 11x plus 6. So when I make my t-chart, 3 times 6, a times c, is 18, and the b term is 11. So I need two numbers that multiply to give me 18, but add to give me 11. So I might try 6 and 3, but 6 plus 3 equals 9, so that's not right. I might try 18 times 1, but 18 plus 1 is 19. That's still not right. But then, hey, I try 9 times 2, and 9 plus 2, that gives me 11. So that means 2 and 9 right here are the numbers I need to use. So now I'm going to split the middle of this thing. Move this out of the way. So I'm going to rewrite my problem. Instead of 3x squared plus 11x plus 6, I'm going to split 11x to be 2x plus 9x. Because again, those are the two numbers I found down here below. But I have to rewrite the rest of the problem too. So 3x squared in front and plus 6 in the back. All right, and we have split the middle. So now in the next page, we're going to end up fully factoring these things. So this says factor by grouping after splitting the middle. So once we have split the middle of ax squared plus bx plus c into our new 4 terms, ax squared plus dx plus ex plus c, we just have 2 steps left. We're going to put parentheses around the first 2 terms and the last 2 terms. If e is negative, we're going to make sure to put an addition symbol in between them. So if you don't know what I mean by that, go back to the previous lesson and recall that when there was a negative sign in the middle and we put parentheses, we need to add an extra addition symbol. So if it says ax squared plus dx minus ex plus c, we have to take that negative sign and keep it on the ex, which requires us to put this additional addition symbol in the middle. All right, then we're going to factor the GCF out of each set of parentheses, and then we'll factor the set of parentheses that match out to the front. So number 3, you might notice it's the same numbers from before. So 2x squared minus 5x plus 3, this looks just like number 1, but I'm still going to start from the top. So 2 times 3, a times c is 6, and then b is negative 5. I need two numbers that add to be 6, or sorry, multiply to be 6 and add to be negative 5. So I might try 3 times 2 or negative 3 times negative 2, but we already know from before that 3 plus 2 didn't work because it was positive 5. Negative 3 plus negative 2 did work because it added up to be negative 5. So negative 3 and negative 2 were my numbers, which meant I could split this into negative 3x minus 2x. And the rest of the problem, 2x squared and plus 3, stayed there. All right, so now we're going to put parentheses around the first 2 and the last 2. So parentheses around 2x squared minus 3x. But because it's a negative 2x there, I have to put parentheses around the negative 2x plus 3. And then I need to put this extra addition symbol right there. Because if I don't put that addition symbol there, then this problem doesn't stay the same in this next step. Okay, so I need to make sure that this negative sign stays on the negative 2. And that I put this extra addition symbol there to keep the equation the same as it was before. All right, now to factor this, the first set of parentheses, 2x squared minus 3x, I can pull out an x, which leaves 2x minus 3. And my goal for the second set of parentheses is to make it look exactly the same. Notice right now it says negative 2x plus 3. So to make it look the same, I need to turn negative 2x into positive 2x. I'm going to pull a negative 1 out to the front, and that'll leave behind positive 2x minus 3. Because when I distribute this negative 1 back in, notice it would become negative 2x plus 3 again. All right, so now we have 2x minus 3 and 2x minus 3 are the same. Those come to the front. And that leaves behind x from the first set and a negative 1 from the second set. So down here at the bottom, we have fully factored the original problem. Okay, number 4, we're going to factor by splitting the middle again. So this time we're going to look back up what we used before. We had 3x squared plus 2x plus 9x plus 6. I'm just going to go ahead and bring this down because we're doing the exact same problem. So we split the middle into 2x and 9x. Then we put parentheses around the first two things. So parentheses around 3x squared plus 2x and parentheses around 9x plus 6. Notice this time, I didn't have to put an extra addition symbol because that middle term was already positive. In the other one, though, we had a negative term in the middle, so we had to be careful there. All right, now I'm going to pull out the GCF. So the first set has an x in common. That leaves 3x plus 2. The second set, I'm trying to make it look the same as 3x plus 2. In order to do that, I need to pull out a 3 to the front. So dividing 9x by 3, I get 3x. And dividing 6 by 3, I get positive 2. Then I can see this 3x plus 2 is the same in both. And I'm leaving behind an x from the first set and a 3 from the second set. So 3x plus 2 times x plus 3 is the fully factored version. All right, now let's look at a shortcut real quick. So the shortcut is when a equals 1. So if the leading coefficient of the polynomial is equal to 1, we can skip some of the middle steps. The leading coefficient is the a in the ax squared plus bx plus c. So all we have to do is, if that's 1, well, I'm just going to show you. It becomes so much easier, guys. And this is probably what you've seen in the past, but remember, this is a shortcut. This is not the starting method. Okay, the next one, by the way, the bullet point says always check for a GCF. So in number 6, we're going to have one step before we do the shortcut. All right, number 5 first. We're going to make a t-chart here where we have a times c in the top left. So 1 is the a here, times negative 10 is just negative 10, and the b term is 3. So I want two numbers that multiply to give me negative 10 and add to give me 3. I might try 10 times negative 1 multiplies to be negative 10. I might try 2 times negative 5. I might try negative 2 times positive 5. And you just keep trying things until you find something that works. So 10 plus negative 1, that was 9. That's not right. 2 plus negative 5 is negative 3. That's not right. But negative 2 plus 5 is positive 3. So negative 2 and 5 are the numbers we want. So I can split the middle, 3x here, into negative 2x plus 5x. For this one, I'm going to do it the long way, but then we're going to see the shortcut appears. So I put the x squared in front and the minus 10 in back. By splitting the middle, like I just did, I can now factor by grouping. So I put parentheses around x squared minus 2x and parentheses around 5x minus 10. Let me move this t-chart more out of my way. I'll put it up there. Okay, now we pull out the GCF. So x comes out of x squared minus 2x to leave me with x minus 2. And 5 comes out of 5x minus 10 to leave me again with x minus 2. Notice the x minus 2's are the same, so I pull those to the front. And that leaves me behind x plus 5. Okay, so now you're probably thinking that wasn't a shortcut. We just did all the same work, but now we can see what the shortcut is. That way we can use it on the next one. So notice my answer, x minus 2, x minus 5. Well, where have we seen negative 2 and positive 5 before? Up here in the t-chart. It's the two numbers I highlighted at the beginning. So the shortcut is that when your leading coefficient is a 1, okay, so we have 1x squared there in the front. When you make your t-chart and you find these two numbers, you can go straight to the answer, x plus the first number, x plus the second number, where in this case, because 2 was negative, it's x minus 2, and because 5 was positive, it's x plus 5. All right, so we're going to use that shortcut in the second one, or number 6 here. But number 6 has a GCF, so we need to pull out the GCF first. You always want to check for a GCF before you start to factor, because if you look at number 6 right now, it looks real tough. Like, it looks like we don't know what to do with that. But if I pull the GCF out, it's actually going to look quite easy. So I see 2y to the fourth minus 4y cubed minus 30y squared. These all have a 2y squared in common. So I'm going to pull 2y squared to the front. 2y to the fourth divided by 2y squared is just y squared. Negative 4y cubed divided by 2y squared is negative 2y. And negative 30y squared divided by 2y squared is negative 15. All right, so now this might still look kind of bad to you, but notice that we have we have 2y squared in the front, and then what we have over here looks very similar to the number 5. It's just a trinomial. We're using the letter y instead of the letter x, but that doesn't matter. So we can factor the part I underlined in red using the shortcut that we just used. Because the leading coefficient of it is 1, all we have to do is make a little t-chart where we do a times c is 1 times negative 15, so that's negative 15. The b term is negative 2. So now I want two numbers that multiply to give me negative 15, but add to give me negative 2. You might try 3 and negative 5, or negative 3 and positive 5, or maybe you try 15 and negative 1. Okay, you can try as many numbers as you need, but 3 times negative 5 is going to work because 3 plus negative 5 equals negative 2. So up here at the top, these are the two numbers I need. So now instead of splitting the middle, I'm going to go directly to this red part is y plus 3 times y minus 5. I don't have to do any extra work. I just take these two numbers and go directly to y plus the first number, so y plus 3, and then y plus the second number, but since it's a negative 5, it looks like y minus 5. We can't forget, though, about the 2y squared in front. That didn't go anywhere. It's still there. So now our answer is all three of these things multiplied together, and that is the fully factored form of 2y to the fourth minus 4y cubed minus 30y squared. All right, so that was the AC method and also the shortcut of the AC method. Most of you guys had probably seen the shortcut before, but thought that you should just do guess and check all the time. No, no, no. Make a t-chart like I did for each problem, and then split the middle. And if the leading coefficient happens to be a 1, okay, if that leading coefficient happens to be 1, then you can do this shortcut. But please do not try to do guess and check all the time. Okay, if I give you a problem similar to number 4 here, don't just try to go directly from this problem to the answer, because although you might get there quickly sometimes, I promise I can give you numbers that are annoying enough that you're not going to be able to just see what the answer should be right away. So don't do guess and check. Learn how to split the middle and go through all of these steps. All right, if in class I see you guess and checking, I am going to call you out on it. So please practice splitting the middle, the AC method. It will help you a lot in the future. All right, see you guys next time.